Hi everyone, and welcome to our video on evaluating inverse trig functions. So in this video, we're going to find angles. So that's what inverse trig functions do. They find angles. So it's working the unit circle backwards to find an angle. So for instance, on this cosine inverse of negative square root of 2 over 2, what it's saying is, let's first make our circle. So here's the unit circle, but cosine inverse needs to get cut in half this way, where we only look at the top half of the circle. So we have 0 to pi is where that answer is. So it's some angle between 0 and pi, and then that negative radical 2 over 2, that is an x coordinate. So remember, cosine's connected to x, so this is an x coordinate, and a negative x coordinate of negative radical 2 over 2 is over in quadrant 2. And so what we need to do is just figure out the angle. Let's get one more color. We need to figure out that angle or t value that takes us into quadrant 2. Okay, so the green can't see as well. Let's just make it extra bold. Okay, so that's what we need to find. And then, well, using our unit circle, we think, well, right in the middle of quadrant 2 would be 4 in the denominator for our angle, and then 3 pi in the numerator. So this answer is 3 pi over 4. Okay, typically we do radians as our answer, but it could also be in degrees. So it would have been 135 degrees if we converted it. Okay, so that's how we break these down. I've got a longer explanation on inverse trig in a different video that I'll put in the description. So if you need more than this, use that. But let's continue onward with this. So notice cosine inverse is cut in half, where we're only looking at the top half. Sine inverse, when we have to do a sine inverse problem, we're going to cut it in half also, but down the middle, or downward, up and downward, where we're only looking at the angles in quadrant 4 and quadrant 2, where the quadrant 4 angles have to be negative. So this is our range for these answers. So an angle between negative pi halves and positive pi halves. Okay, and then we see, okay, sine inverse of radical 3 over 2. Let's use, that is a y coordinate. So again, sine's connected to y on our unit circle. So it's saying this is a y coordinate this time, and we need to go backwards to get the angle. Okay, so that's the y coordinate up there, and we could label the whole thing. Okay, so there's that y coordinate, and then now we need the angle. Let's do that in purple. From there to there, and then we see, oh, it's close to the y-axis. Close to the y-axis means it's 3 in the denominator. It's in quadrant 1, so that must mean it's pi thirds. Okay, so that's our answer. Again, in radians, if we need to, or if they want it, we can change it to degrees. So it's or 60 degrees. All right, arc sine of negative radical 2 over 2. So this is the same thing as sine inverse. So they just use different notation. Sine inverse of negative radical 2 over 2 is the same thing. And what we'll do is, again, just draw a circle. We'll still cut it in half downwards. So our answer still is between negative pi halves to positive pi halves. And then this is an x, or not an x, this is a y coordinate because it's sine. So it's connected to the y. And that would put us down in quadrant 2. Okay, so we've got the full point would have been square root of 2 over 2 and negative square root of 2 over 2. Okay, and then we need to figure out the angle there going clockwise because we need a negative angle. Well, going clockwise into quadrant 4, right in the middle of quadrant 4, would mean that our denominator is 4. And then going clockwise just a little bit would be negative pi in the numerator. Okay, so we're still just using our unit circle. Now, arctangent, that's also tangent inverse, so they can show different ways to write the same thing. So this is the same thing as tangent inverse of negative radical 3 over 3. Okay, so tangent inverse or arctangent work the same way that sine does, inverse sine does, where we would cut it in half down the middle. And our answer has to be between negative pi halves to positive pi halves. So it's got to be an angle between there. Okay, and then we'll look at our tangent. Okay, so this negative radical 3 over 3, that is found by taking a y coordinate and dividing it by an x coordinate. Okay, and then we're going backwards to get the angle. Okay, so our y coordinate divided by an x coordinate, that would make that happen. So it is negative, so we know we're in quadrant 4 based on the boundaries that our range is in. And it would be the one that's closest to the x-axis because that point has square root of 3 over 2 and negative 1/2. And so notice when these get divided, let's put that scratch work right there, the 2's would cancel, and then the square root of 3 in the denominator would get rationalized to make negative radical 3 over 3. So we did find the point, we just have to figure out, well, what's the actual angle there? Okay, so just a little bit down going clockwise, close to the x-axis means it would be negative pi sixth. Okay, or if they want them in degrees, so this would be or negative 30 degrees, and I didn't do the other one. This one would have been or negative 45 degrees. Okay, so there we go. So that's how we find these inverse trig functions. So it's finding angles. So it's going backwards. When we're doing an exact value, it's still just something on the unit circle. Just make sure to cut up your circle the correct way. So cosine from 0 to pi, sine and tangent inverses negative pi halves to pi halves. Okay, so thanks for watching. See you again next time.